Okay. Just ping him.
Mhm. He went to the wrong room. Should be coming in a second.
Thanks for that update, Jim.
I'm sorry?
I said thanks for the update.
There he is.
All right. So, Ra, are you ready to give a
Technical update.
technical update? Yeah.
Yes, I am.
Awesome.
And I'm going to share. I was in the wrong room for some reason. I don't know. Okay. Hey, I think you should be able to see my screen. Can you confirm that?
You do.
Yep. Very good.
Okay. So we have started Sprint 37 this week. We have been continuing to analyze and look at solutions for the long proposal times. The cost accounting work is ongoing. We have increased the number of people that are working on cost accounting. And then the testing Casper, independent of the network layer, that's also beginning to be done. And then there is, in general, increased testing of across the system type of scenarios, including validator slashing. The peak merge functionality is getting close to complete. And we have a solution for that we're implementing now, and I'll speak to that a little bit later on. And we have an API to replace the listen for data at name. That's in review right now, and then after that, we should be able to complete that within the current sprint. One thing we have started to look into is the mechanisms for increasing network safety, reliability, and hardening. Basically, certain kinds of contracts or loads could be dangerous to the network, and we're trying to figure out how we can identify them a priori and what we need to do to protect against that. So there is analysis and planning in progress for that, as well as the first iteration of launch plan. We have started a document, and we're beginning to meet together to really figure out what all is needed for launch. On the Genesis vault creation ceremony, in the last meeting, we said that we have required signatures. We have a proposal to resolve the required signatures. So that has been completed and has been tested. And so that's merged in now. So when we get the next release of the node, we should have that available. And I already said for cost accounting, we're trying to, there is still a completion risk on cost accounting, but we are trying to increase the team and then specify the tasks more to reduce that. One of the big things that has been holding us back last several weeks is this issue of long proposal times. And we are continuing to investigate that. And basically what is happening is that as different validators propose over time, if one or more validators fall behind, that problem seems to get worse and worse, with basically there being a leader and then everybody else is finding it hard to catch up. So that's basically what we're trying to, so we're calling it the rabbits and tortoises type of a scenario being created. So we had extensive discussion on that this morning. There is still more data being conducted. Actually, we were hoping that Sebastian would be able to show some of the analysis and data, kind of data and behavior that we're seeing, but he's not available at the moment. But hopefully sometime in the next couple of weeks, we'll be able to expose a little bit more of the analysis and the thinking and hopefully resolution or potential solutions for this. So we have a meeting scheduled for tomorrow morning to go over that, and that's kind of an ongoing thing. One of the things that's slowing us down in this process is the fact that this behavior shows only over time. It's not instantaneous. It's not something you run a test and you immediately know there is a problem. It's a cumulative behavior. And so that's why it's taking us a while to, first of all, get to the results, and then correspondingly the analysis also gets delayed based on that. In terms of replacing the old registry with Rolang-based registry, one issue has been replayability in peak. So we have a solution for that we will implement that should work. There may be a longer term solution that we need to think about and have some discussion about that, and then bring that in at a later time. There's more details about the current proposal at that link I'm showing here with the replay issues. And while I'm at that, let me just share this document in the chat. There's the link to the update. So we will be releasing 0913 sometime during the current sprint. The other work that's going on kind of related to this listen for data at name that I mentioned about is that we now have an API implemented for DAG discovery and block discovery. And that should enable us to implement a full alternative to listen for data at name. So there are 3 tickets, 2 of them are in review, so very close to completion, and then the other one will be worked on. In Casper, one of the things that we're doing, actually there are a couple of things in Casper. There is tests for slashing and the slashing behavior work is going on. That's one thing. Another one that's going on is to work on a non-gameable source of randomness for the validator to pick among the other validators. And that there are some prerequisites for that, and we're basically working on that right now, so that we'll have a random selection of the validators without gaming or without enabling gaming by anybody. So that's where we are. And then increased testing by dev team. Basically, everything that we're doing there is ongoing work. Most of it, I think I have mentioned last time. We have created an extra developer testing network environment to separate out the long-running tests, and in general provide the developers more test environments over which they can do the testing, so we can get through some of this hold up that we're getting through long tests. In the community testing, I mentioned a while ago that we had 300 contracts that have passed and a bunch of other contracts that have not. Matt Zipper has completed some analysis of that, and he identified 50 more contracts that are usable, and the rest have syntax errors. So either the repo owners or somebody else needs to fix those contracts and bring up the syntax to current for us to be able to use that. But for now, we are adding these 50 contracts also to the 300 that we can occasionally run either sequentially or randomly to basically expand the variety of contracts that we're using for testing the system. In that process, we have discovered that basically some type of contracts are causing out-of-memory errors, specifically in terms of running the out of JVM heap. So we're going to discuss that and figure out how we can, if there's a way to characterize things that would be harmful to nodes being brought down or the network becoming unsafe. And so that's work to be done to really figure out, is there a way we can characterize things, or can we identify or specify limits on certain resources such that we, as for example, on the block size. That's a conversation that is also beginning to happen. The refactoring and optimization and bug fixes, there are a bunch of them that are ongoing. I just highlight here one example, which is refactoring validate.scala to use either T. So that's, but there are many others. I'm just giving you that as an example here. And on the getting the third parties, us getting ready to give documentation to third parties. I think I misspoke last time saying that it's close to completion. I discovered later that that was not necessarily the case, but we are working on that issue to create documentation so that others like wallet providers or exchanges can engage with us, that they have necessary information to engage with us. So that's my technical update. Unless there are, Greg, did you want to add anything to what I said first before we open up for questions?
Yeah, thanks for asking, Ralph. First of all, and thank you for a good detailed technical update. That was great. I just want to let people, sort of chew on the dynamics that we're observing. So what we're observing is that when a validator who proposes a block gets by the time they propose the block, they have already done the play and the replay, and so the other validators who receive the block will be doing a replay, and that will put them at a processing disadvantage, even if they're the same exact same configuration in terms of memory, compute horsepower, etc. And so if the contracts get large enough, or come at a particular frequency or some combination thereof, they can get behind. And if there's enough delta, they can get far enough behind that we start to see the long proposed times. And so essentially, if you've got a rabbit that sort of gets out of the gate, it ends up being the one that dominates in terms of proposing. And so what we're looking at is some kind of constraint on, and there are a range of possible constraints. One of them is just putting everyone on the level playing field with respect to the replay. So separating out block validation from replay is one approach, and then having the propose go out with the to the other validators, and they all are in the state where they have to replay. So that would put them on more level playing field, but it's not a sort of permanent resolution to this problem. So it's essentially there has to be some kind of metabolic or other kind of constraint on validators, so that they kind of go through a cycle, sort of like a diurnal cycle for critters that sleep one part of the day and work or forage during another part of the day. So we would need a similar kind of cycle for validators, so that they're proposing for some period of for some chunk of work, a natural chunk of work, and then they're processing for some chunk of work, and that kind of cycle can be made independent. I'd much rather have a cycle like that than the other proposal, which is that the other validators tell validators that are pulling out ahead to slow down. But that's another way to approach the problem. But essentially, there's a biological phenomena happening in networks like this, where even tiny little differences in processing can lead to large scale differences later, because they're all communicating and the communications are iterative. So let me just stop there and check in and see if people kind of understand the issue that we're dealing with. It's an equilibrium issue.
So Greg, is this a unique hurdle for RChain?
No. Every communications protocol is going to have to deal with this. So, for example, in Bitcoin, what happens is the complexity of the challenge will be ratcheted up in order to slow validators down or slow miners down. So essentially that's a way to throttle behavior, and so we have to introduce a similar kind of throttling mechanism. And one is, of course, this sort of metabolic throttling. So if you go back to the rabbit and tortoise kind of setup, and part of the reason I was using these biological metaphors is to give people a sense of how ubiquitous these kinds of equilibria problem are. So a rabbit is faster than the tortoise, but the rabbit's metabolism is also running at a much higher speed. And so while the rabbit can just burst out of the gate, the issue is that the rabbit burns up a bunch of calories in doing so. Similarly with hummingbirds and all kinds of things that have these aspects of their behavior which are incredibly speedy or fast in some way. But it comes with a metabolic cost, right? The metabolic cost is that the hummingbird has to eat all the time, the rabbit has to sleep a lot, these kinds of things. So my druthers would be to follow nature and introduce some kind of metabolic cost here, not necessarily a token or anything like that, but a natural work cycle. And we kind of know what the limit is, right? The limit is that all the rabbits in the network are kind of go off to their own shard. Whereas and we have to be careful because it's not just that, like you can also have a situation where one rabbit, even though they're all equally horsepowered, as that's a bad metaphor, they're all equally rabbit powered, can still pull way ahead of the others. So you have to introduce some kind of equilibria reestablishing mechanism, and that's what we're debating is sort of the best way to introduce that and know where the limit is, right? The limit is that the ones that can pull away go off to their own shard, and they don't play with the tortoises. So we're trying to see if we can find a way to within the protocol, get as near to a limit like that as we can. Does that make sense?
Yeah, it does. I would imagine Ethereum runs into the same thing, and
every
right.
communicating network. I mean, this is so ubiquitous. Every communicating network runs into this. Ethereum, as currently, like any proof of work network, can address this by bumping up the complexity of the challenge, right? So the miners have to spin more, guessing numbers. Does that make sense? So you bump up the complexity of the proof of work, and so they spin, and that's a throttling mechanism. So we can introduce something similar to this. It's just the question is, what's the best way to do this? For example, in C delta, stake was diminished over time, so you're burning up your stake, and that ends up being a kind of metabolic challenge. So essentially, that's what has to happen is we have to introduce some kind of metabolic like throttle, whether it's a sleeping waking cycle, so there's two different kinds of work, or you're diminishing some resource or something like that. But that's the class of solution. And I'm not being super technical in this conversation because this is a community update. We can get as technical as people want to go, but maybe just keeping it at a high level, just to give people intuitions as to what we're talking about here. And these kinds of equilibria phenomena, are much more. They're things that you can only discover, once you have a reasonably detailed model. So in this case, the reasonably detailed model is the network itself. But you can't know, and if you don't have something that's close enough to the actual network, then you can kind of you make these equilibrium model and then just way off because there's some aspect of processing you didn't see. So these are the kinds of things that we expected, and I'm looking forward to solving this little puzzle. It's a good one.
Thanks for the explanation.
Yeah, sure. No worries. Thanks for the questions. Any other questions? Go ahead.
No, I was going to say, go ahead, ask if there are any other questions, but I was going to say that Sebastian has joined us and he can show some of the metrics and data that he was measuring.
Awesome. That would be really good. I'd love for Sebastian to do that. Yeah. So I just want people to get a sense of the way in which we're going about solving these problems, how we're collecting data so that people understand the sort of the level of effort that goes into observing these problems and then tackling what the best solution is. So Sebastian, if you're ready, please feel free to go ahead.
Yes. Hi, I'm ready. Sorry for the delay.
No worries.
I would like to show you some metrics. What I captured last week in my investigation on long proposal times. I can share one of the images. Okay. So last week I ran a network DevNet of 5 validators and tried to investigate long proposal times, long proposal time. And I started with one propose, every minute, just a very simple hello world contract, and waited for a couple of hours. And it turned out that the network did fine. The block propagation, the replays of blocks went fine, and there were no network degradation. So I moved on to 4 or 5 proposals per minute on 5 different nodes, and after a couple of hours, it turned out that it was still fine. Then I moved on to a more complex contract from the examples folder called dupe.rho, and ran it on one validator. After a couple of hours, everything was fine. So I moved on to 2 proposals per minute dupe contract, which I believe runs 100 times. Yeah, it's like a recursive contract. And waited then more than a couple of hours. I waited for 2.5 days, and wanted almost to move on to 3 or more auto propose per minute. But then I discovered some anomalies. As you can see in this Grafana metric, you see on at the top overall proposed total times. And then the proposal consists of 2 parts. One is block creation, and the second part is adding the block to the blockchain. And as we can see, there are like hiccups, right? So propose times took 1 second or 10 seconds, but there were times where it started to become 12 seconds and more, 1 minute. And so I moved on, not moved on, but I kept the network with 2 proposals of the dupe contract per minute. And then I discovered, let me change the share. Where is my control here? Share a different picture. Here we go. Okay. Now we see last Friday at some point an escalation where the proposal times, yeah, how do we call it? It freaked out. Yeah, it's it went up to 2 minutes. Yeah, and mostly the most of the time the 2 minutes were burned in the block creation. You can see at here it's 12 o'clock. It's Central Europe time. That the network started to ran into a deep degradation, where where the proposed times randomly went up to 2 minutes. I believe if I would let the network run for a longer time, it will be soon 3 or 4 minutes. But I decided to restart the whole network, but without deleting the working directories, the block data, just to see if it's related to data that we have written to the disk, or if it's something that is related to some processes in memory. But as we can see, it's truncated, right? But we can see that after restart, the nodes, the proposal times went back to 10 seconds. So it's some problem that is in the runtime, in memory of the node. Let me share a different picture. Besides measuring the overall proposal times, I have also very low level R space or tuple space read and write times. Let me share a picture of that and share. So now we see there are 3 different stores in R space. It doesn't matter the details, but all at the same time, more or less, started the written, especially the write times, skyrocket. Yeah. So normally we have write times around 10 milliseconds, and we saw write times for one single transaction of inside such a transaction is running one deploy or terms, rolling terms are running. So we have many of those rolling terms running on the tuple space. So 10 seconds for one such a transaction on a store is not acceptable. It's extremely long. So, but the strange thing was about this that all block stores, not block stores, or RSpace stores and 2 other stores, block store and dex store, at the same times showed this anomaly, extremely increasing in access times to the data stores. So my conclusion was that it's maybe not really related to the logic of R space, of the tuple space, and it might be something else. So I checked a different system, metric system. It's where we collect more machine metrics. We're calling that collect D, and I have one metric. It's the interface network traffic measurement. I can show you, and as we can see that in the upper we see bytes per second sent over the network interface, and in the lower one at the bottom we see packets per second, but it's related. We can see that over time the nodes are sending even more data. The data that gets sent over the network increases. So I don't have a screenshot of the metrics related to disk I/O, but it looks very similar. So we have the suspicion that we are streaming too much data of the network, too much packets, too much blocks from one block, from one node to the other. So one scenario could be that the nodes are requesting missing blocks over and over again, and the other nodes the peers in the network are responding, are starting to stream the block over and over again, and we are writing the blocks to disk, and that might explain why we have so much network traffic, why the network traffic is not like stable or flat, but growing. Let me check. Yeah, also an overall system load of one node. So as we can see here that the overall system load for here, it's, for example, node 1, was also increasing since Wednesday to Friday. And then we can see that I restarted Friday again, 12 o'clock, where we restarted the node, that the system load went down. So it was the node. Yeah, it wasn't something outside running of the node. And then it went up because after restart of a node, we are fetching a lot of data from the disk into memory, and yeah, dehydrating some internal states. So So the peak at after restart is normal. So it's not nothing to consider. Let me check. I believe that were all my pictures. I don't have more. Yeah, that's it. Actually, we are now investigating the algorithm that requests missing blocks from other peers, and hope that we will find here the problem for the long proposal times. That's all from my side.
Thank you very much, Sebastian. I really appreciate that presentation. Does anyone have any questions about this? Great. Okay. Well, because we had the long weekend, there's not much in terms of business updates. We're still talking to lots of exchanges. We just had a good conversation with some advisors in Malta as a part of getting listed with Bittrex International. That could also result in some nice data for any some supporting data on the token analysis, because they'll do a legal analysis on the token for the European jurisdictions. So that's something that we're pursuing actively. And apart from that, I don't have any other updates on the business side. I guess we can share some more updates on the members Q&A session, but I think that covers everything we wanted to talk about today.
Just a reminder, Ian, did you want to do the reminder about the nominations? Or?
Sure. The deadline for submitting your application to become to be a nominee for co-op director is September 8th. And you can find out more about that if you email nomcommittee@gov.rchain.coop. That's nom-cmte@gov.rchain.coop.
Awesome. Thanks so much to everyone, and see you again next week.